For number 3, it's a little bit different than the last 2 examples we just did because it's not in factored form right now. Notice the top here, we need to go ahead and factor that. So we're going to get x minus 4 times the quantity x plus 1. Notice every factor in here on the top and the bottom are all linear factors raised to odd powers. For the x-intercepts, set the top equal to 0, so we get 4, 0, and negative 1, 0. For the y-intercept, when x is 0, we're going to end up with negative 4 over negative 2, and that's just 2. And then the vertical asymptote is at x equals 2 from here. All right, the horizontal asymptote, or the oblique, is a little bit more work here. Notice the degree on top is more than the degree on bottom. So as a result, when we divide, we're going to have an x in part of our quotient. All right, and because of that, there is actually no horizontal asymptote. It's going to be an oblique asymptote. Now, if you recall, when we divide to find the oblique asymptote or the horizontal asymptote, it's always y equals the quotient. So you might find that you're dividing and you get a remainder and you're like, oh no, it doesn't factor evenly. That's okay. We're not concerned with the remainder. We're only concerned with the quotient. So if we go ahead and do long division, that's kind of nice because then your remainder's at the bottom. You're not even looking at it. The quotient's on top. But some of you prefer to do synthetic division, which goes just a little bit faster. So we have 2 is our root. That's what we're divided by here. And then we have 1, negative 3, negative 4. All right, already I know I'm not really worried with this remainder. So I'm just kind of taking a look at this part, and that's going to be my oblique asymptote. Bring down the 1. 2 times 1 is 2. We have negative 1. And again, if you kept going and we get negative 2, then we would have negative 6 is our remainder. Okay, but for our oblique asymptote, remember this is my constant. That's my x term. So it's y equals x minus 1. All right, well, let's go ahead and graph that. We go down 1, and then the slope 1. So here is my oblique asymptote. Okay, we have a vertical asymptote at x equals 2. So that is right here. And because we only have one vertical asymptote, we know we're looking for 2 branches. We have a couple points. 1, 2, 3, 4. 0 is right here. And 0, 2 is up here. So that's kind of a giveaway for where the branches are at. I'm going to have 1 on the top part here. Let's go, negative 1 here was also one of our intercepts, so I'm going to just come up, boop, 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 boop. And then on this side, notice vertical asymptote, this end is up, which means my other branch is going to have to start down because it's an odd power. If that were even, I would have a branch in here instead. Okay, but this is odd. It's going to come down, goes through, and our graph looks somewhat like this. Okay, as we approach 2 from the left, we're increasing without bound. As I approach 2 from the right, we are decreasing without bound. And as x gets infinitely large, notice we're just going to keep going up and up and up. So this actually is increasing without bound. And as x gets infinitely small, so really small, this is also going to decrease without bound. Right. Now number 4 is going to tie everything together that we've done in the last 3 examples, but this one's a little tricky because they're expecting you to sketch a graph based on the information. Okay, so now we aren't graphing and using the information to answer limits. We're going to be given the limits first and then graph based on that. So we had talked about on example number 1 and 2, if you have x approaching infinity, negative infinity, these are your end behavior asymptotes. So this information that they are giving you right here is your horizontal asymptote. Okay, and then here, notice we're approaching 3 from the left and from the right, and that is approaching, or that's an unbounded, it's increasing without bound. Then what this is this is a vertical asymptote. And then notice -2 from the left and from the right also has unbounded values. And so that is also going to be a vertical asymptote. So they're giving you all these pieces of information just from writing these limits out. Right? So then if we want to put this all together now, then we're going to have a horizontal asymptote at 1. We're going to have a vertical asymptote at +3. We are going to have another vertical asymptote at -2. Okay, so now we have the values. Now we go back and we're going to take a look at what happens at those. So horizontal asymptote doesn't matter. That's a 1. So we, at this point, are just trying to figure out, are we above or below? So we're going to use our vertical asymptotes to do that. When I approach 3 from the right-hand side, we are going up. So this needs to be up here. But notice when I'm approaching 3 from the left-hand side, that is also increasing without bound. So that is also up. When I approach -2 from the right-hand side, we're down. And when I approach -2 from the left-hand side, it is up. Okay, so that tells me that this is going to look something like this. This needs to come down here, and this is a branch that's going to stay on this side. All right, moving on to part B. Here's our horizontal. Here's our vertical. And because we're approaching -1, that's another vertical. All right, so horizontal at 3. Vertical at 1. And vertical at -1. So we use the vertical asymptotes to determine the arrows of the branches. Around +1, both ends are decreasing without bounds, so both ends are going to go down. At -1, if I'm coming from the right, it's up. So here's -1. If I'm coming from the right, it's up. And then on the left-hand side, it is going down. So then I know my graph looks like this. You're just going to finish the branches. Okay, now obviously this is just a sketch. We don't know where the intercepts are at, anything like that. You know, we don't know if this would be a rational function where this would cross and really stay above. So this is really oversimplified, but by looking at this, it's really being able to draw a sketch of the graph really tells whether you understand what this notation is trying to tell you. So I'm going to leave C and D for you guys to do on your own. You can go ahead and check the notes online and check your work and just make sure that you know how to do those.